All right, well, thanks for coming. And the first thing I need to say that is my brain is basically at its sharpest at 4:30 a.m. and it's now currently mush. So, so if I stumble into total incoherence at some point, just poke me with a sharp stick, and I'll probably wake up again. Um, I asked Rose about back in October if I might do a talk on ROS, and at the time I was literally just going through the first beginner tutorial on the ROS website, and I'd have no idea where I'd be at this point. So, but it turns out the tutorials are just unbelievably good, and there's a tremendous amount. Is that Melanie? they're just awesome. Um, there's there's no excuse not to try to learn ROS. That's for sure. And the other thing I got a tremendous amount of help from is just people out there in the world, and one in particular, I just make a shout out to Mike Ferguson at Albany, he's just unbelievable. He's on the ROS and Robotics forums, and we now even have a sub forum specifically dedicated to ROS, and he's sort of single-handedly pulled me and a whole bunch of other hobbyists into ROS by being online 24/7 and just ready to answer absolutely any question we might have. The other thing I have to warn you about is the last time I ever gave a presentation, I was still using transparencies on an overhead projector. So I've actually never made one of these fancy presentations before, and I'm using OpenOffice's Impress because, of course, I'm not going to use the other one. Um, and so we'll see how this goes. I think this is how you do it. So this, just for fun, I made this little thing called Wordle, and you can do it with any of your robot pages. This is I copied the text of my head tracking tutorial into the Wordle text box online, and then it gives you this little picture of all the words with the size being proportional to how often they were used in the text. And of course, you can see ROS got a lot of attention in that particular tutorial. So I'm quickly becoming a fan. One other thing I'd like to say is anytime during the presentation, feel free to interrupt and ask questions. I have no particular need to get through this all or in any particular order. So the title of the talk is ROS for the Rest of Us. And by that I mean ROS really started out in the university world, in the university labs, very particularly. I think there was a good chunk of it at Stanford and has a long traditional history in Stanford. And of course, Willow Garage itself has essentially demonstrated it out there in the world at large on their premier robot, the PR2, which is a $400,000 robot, which is out of our reach. So the question to me was, would it be possible to run ROS on the kind of hardware that we use and to do the tasks that we like to do with hobby robots? And so I took the plunge, and it actually took me a little while to make that decision. Partly, it's ROS is only 3 years old. You know, they just celebrated the 3-year birthday a few weeks ago or a few months ago. And I'm not brave enough to dive into something that's just getting going. So I did want to wait for it to come to sort of the Debian package level rather than the level that I had to compile on my own. I am a Linux network administrator by day, so I'm familiar with Linux, but unfortunately I'd slipped into the world of Windows robot programming, which is really, really easy. Everything's done with a GUI. You know, in Visual Studio, you have drag and drop controls into nice, pretty forms. And RoboRealm, as a couple of you have mentioned, is just an unbelievably easy package to use for visual processing. It's a great learning tool. You can drop any kind of filter from edge detectors to Fourier transforms. Even today, they just released, or within the last 6 days, they released an object recognition module based on all sorts of different feature classifiers. So the Windows world is actually a very tempting world to stay in to program robots. But nonetheless, I wanted to take a look. So Willow Garage and ROS, of course, come as kind of a pair. Willow Garage is .com and ROS is .org. And ROS is where all the real machinery gets built for the software end of things, and for where you can go and get pretty much everything you need to know about ROS, and I'll talk a little bit about what kind of resources are on that site and how they can help you get going. So what is ROS? Everybody here knows, of course, it stands for Robot Operating System, and usually they like to insert meta in front of operating system because, of course, it is still running on a computer operating system, particularly Linux. But more importantly, it's a publish-subscribe model in a network-centric environment, and provides a set of communications channels for message passing between independently running nodes that control your robot. And for me, the publish-subscribe model was actually rather new. Ordinarily, when you're programming in things like C# or even C++ in Windows or even Python, you tend to just build a program from beginning to end. You can certainly segment out functions and different methods and call them, but you tend to, if you want, for example, the value of a particular sonar module at time t to see whether or not there's an obstacle there, you just query that object. You have some object in your code, some class perhaps, some instantiation of the class that represents that sonar module. You just query it immediately, you know what its name is, and you get back the current value. When ROS works differently, and in this case, we use a publish-subscribe model where that sonar module is actually just running on its own in its own little ROS node, and it's constantly publishing its distance value that it's got onto a topic. And it's like it's sitting out there on a message board, and if anybody cares to read it, they can subscribe to that message board and get the data, in this case, the sonar distance, at any time they want. So it's a different model, and it takes a little while. It took me a little while to get used to, but that's where the tutorials really help. And if you just go through them from beginning to end, for me, familiarity sort of breeds an understanding, and by the time I got through the tutorials, it really started to make some sense. By the way, I wanted to ask this right up front. How many people, besides the Willow Garage folks here tonight, are actually using ROS on their robots? Damn, just 2. And how many are at least exploring the tutorials or online? Okay, a few more. That's good, because that's a great place to start. One of the things I like, third point here, is that there's the standardized units of meters and radians. And this may sound somewhat trivial, but how many times have you actually gone into your own code and tried to figure out, how many ticks of the encoder map into how many inches on the floor, or how many, what is the value, the analog sensor comes back with the value of 923 out of 1024. And does that mean it's 72 degrees for a temperature sensor, or does it mean it's 62 degrees, and so on? And so it's nice to have a standardized set of measurements, because once everybody agrees that we're going to deal with metric, or at least deal with meters and radians in this case, then we know we're all talking the same language. It prefers Linux, as you know, and this is probably the biggest hurdle to a lot of people, I think. But let me see, with a show of hands, how many people are actually using Linux. Oh, wow, that's a much bigger show. So it's not going to be a big hurdle. And the nice thing is, for those of you who are not, Ubuntu Linux and others, but certainly Ubuntu is the one recommended by Willow Garage and the ROS community. It's unbelievably easy to install. You can install it right alongside Windows. You don't even have to repartition your disk, and so you can give it a try without taking any risk. And the other thing, this is what I was referring to earlier, if you spend enough time programming in a kind of a GUI, a Visual Studio style application interface device environment, you may find this feels like a little bit of a step backwards to almost like the DOS world, because now you're dealing with command lines a lot, and terminal windows, and text editors, and not so much the drag and drop stuff. But once again, I think once you start getting used to it, you see that this actually isn't such a bad way to go. And there are GUI interfaces being introduced all the time, and we saw Tully, although we couldn't quite see it because of the resolution problems. There's no reason you cannot create, using WX widgets or something like that, your own little GUI interface to your robot. As a rule, people don't seem to do that right away, because it's easier just to type the command on the command line and get going.
Based on what I would probably recommend using WX Python for your GUI. It's tied to lots of WX widgets, not wrapper.
Right. So WX Python sounds like a good place to make your own, a good tool, good language to use to make your own type of GUI. And then, of course, the two favorite languages for ROS are C++ and Python. And I'm embarrassed to say that C++ still kind of gives me a headache. So but I didn't know Python at all 4 months ago. So I went to the python.org tutorial, and and again, just an awesome tutorial. If you go through the beginning to the end, you know Python basically. And what's amazing about Python to me, and I'm probably preaching a little bit to some of the converted here, is it's like writing in pseudocode. It's you just write it and it works. So I really like Python, and even though it's like the 100th language I've had to learn in the last 20 years, it's one that's nice to use. So you missed the most important one. That warning: ROS is addictive, and it's addictive in a really funny way, because once you get into it, you really kind of start wanting to understand it, and you really want to start using it, because you start getting this weird vibe that this thing is really powerful. And if you don't get through to the point where you're using it, you're going to miss out. So it's a bit of a struggle at first, at least it was for me, but it's a big payoff in the end. So the ROS highlights, what did you sort of get if you make that effort? Well, you kind of get SLAM for free, which is pretty cool. And that includes path planning. And these are some of the things that Tony was showing earlier. And it really is remarkable. And I'll show a quick little video in a moment where you just let your robot run free in your house, and it just produces this wonderful floor plan of your house in about 10 minutes. And then you can tell it to go from anywhere from point A to point B. And I know there's some people in the club that are actually programming this from scratch on their own using particle filters and so on. And that's, to me, that's just brilliant. And that's amazing that people can do that. But if you don't have the time to do that, and just want to get to that mapping level, ROS is going to let you do that out of the box. Now, it's not easy to set up, but it is one of the things that you get rewarded with if you make the effort to get there. Another big highlight is visual processing. This is done through OpenCV, and what you'll find with a lot of ROS packages is that they've actually been around a long time before ROS. So OpenCV has been around forever. It came out of IBM or Intel, I guess it was it IBM or Intel? Intel, I think. Sorry, Intel. Back in, pardon me? Correct. And he's at Willow Garage, I think. Back in 1999. And it actually has a very nice Python set of hooks now. So again, if you're a little C++ phobic, did someone over there do the Python stuff? All right. Thank you very much. It was quite a relief when I saw that. Now, it's still not going to be as easy as RoboRealm, not even close. But it's as more people start using the Python version and more people start writing some tutorials, it'll become easier in that regard as well. It certainly is very powerful in terms of extracting visual features from your video stream coming from your robot's camera. Another big highlight is the point cloud library, something that I've barely even begun to explore. And this is where you have a three-dimensional point cloud, either from a scanning laser or now, wonderfully, with a $149 Kinect camera, you can have your very own 3D point cloud on your Create robot, for example, and dive right into the point cloud library. And the point cloud library allows you to do things like segment objects, three-dimensional objects off a table, recognize objects from their shape, and so on. So it's a very powerful tool, something that would be extremely difficult to do on your own. And the nice thing about the Kinect is a very nice anonymous donor actually just gave me a Vidir stereo camera for PyRobot, and that camera was $1,600, and all it is a pair of lenses and it's tied into a chip that does the stereo correspondence. I say all it does, but it's a very difficult thing to do, and it costs $1,600, where the Kinect is $149, and away you go. Another big feature is ARM navigation, and this is a big one because this is one of the hardest things to solve I think, for hobby roboticists, is not so much the forward kinematics, but the inverse kinematics. So if I ask you if I want your robot to have its hand in this position when the current position is here, how do you drive the joints through various angles to make sure that the hand ends up in that position? And that's a really tough program to do. It's actually something I worked on and solved in a minor way for my thesis 20 years ago. But back then, we were running neural networks with 16 neurons per network, and it took 3 days to simulate the network with just 16 neurons. So it's a new world out there for ARM navigation. So that's part of ROS. And RViz for visualization. Tony had that up earlier, demonstrating the occupancy grid that he was getting from the Nido. This is a really nice tool, and we'll see a few examples of how you can use it. Player Stage Gazebo are long existing projects, open source projects, and they have been wrapped in ROS as well. I actually haven't used these extensively. They're for simulating, sort of practicing your algorithms on simulated robots and simulated environments, including actual simulated physics. So you can even have things bump into each other. And SMAC, am I pronouncing that correctly? Smash, thank you. Hierarchical state machines. This looks really neat, and it's something I want to play with. And it's basically a way for you to set up a hierarchical set of tasks. And a typical one might be go tidy the living room, and that would be the highest level of the task. And now somehow the robot needs to figure out, well, to do that, first I have to get to the living room. Then I have to start looking for stuff that doesn't belong in the right place and move it to X, Y, and Z, and so on. So you can build a set of tasks using this very nice library that was created quite recently, actually. And then finally, my all-time favorite, and hopefully Tully will appreciate this, is this is actually the reason I waded through all the ROS tutorials, and that is the transform frames. Because when you want to control an arm with any more than 2 degrees of freedom, the math just becomes a nightmare. And to solve those kinematics problems it's doable, and I'll show you how I sort of did it for those 2 joints. But the moment you go past 2 joints, it just becomes a big pain. So it's really terrific that someone spent the time, and that those people who are here in this room, to work it out once and for all. And they use quaternions, which are a way to get rid of the singularities and the ambiguities and rotations. And then you just get to use it for free, and I'll show you how powerful that is in a moment. Now, this is a slide that's particularly relevant to this group. It wasn't too long ago that you couldn't make this list. And basically, the platforms that we're focused on first were those that were typically seen in the university labs, like the Pioneers and the Video robots, of course, the PR2. But now there's almost no piece of hobby hardware that this won't interface with. And so in particular, the iRobot Create, the Nido, which is actually a very recent hack, thanks to Hash79, whose real name I still can't find anywhere on the internet. So he remains a mystery at large. And Mike Ferguson at Albany. And then the Arduino was just recently, the AVR bridge was released, and that's what's going to allow Camp's ClubBot to grow up someday and become a ROS robot as well. And we saw a demonstration of that tonight, where we can blink the lights and read the analog pins. And away it goes. The serializer, I actually happen to really like the serializer. I've been using it for a long time, and it's got all sorts of PID controller stuff on it for doing odometry, so that was terrific. But it's basically just supported for .NET libraries, so I was using it in the Windows world. So I have now a Python library and then a ROS package wrapped around that. So if you're a serializer fan, that is now fully ROS capable. And then, of course, for Dynamixels, which are the servos that are being used on PyRobot here, you can control them with a USB to Dynamixel. You can control them with an Robotics. The Lego NXT, Fidgets, Lynx Motion, SSC32, and RoboBoard. These are all now supported with ROS packages. Okay, here's where I get away from these bulleted slides, which are kind of boring. This is the basic idea as I understand ROS, and this is what I wrote a little head tracking tutorial that sort of illustrates the various components. ROS likes to break everything down right from the beginning, and I think it's to our advantage as programmers, into nodes. And each node, hopefully, is pretty small in terms of its code base, so you don't get too lost in the details. And in the case of head tracking, if you wanted to head track a visually moving object, the node that ties everything together, we'll call that the head tracking node. But then we need a camera, obviously, so we can see the objects. We need servos so that we can move the head to the position of the object. And then in between the camera and the head tracker, we need to extract visual features. What is it that we want to track? Are they going to be color features? Are they going to be shape features? What are they going to be? And then to separate out the movement commands from the actual physical hardware of the servos, we'll actually have another node that we'll just call movement commands. And that way, if we want to plug in a different servo controller board, we can do that at a later time. So ROS really encourages this divide and conquer strategy by encapsulating everything in a node. The next thing I wanted to point out is that you don't have to program everything in ROS. In fact, that's almost a non sequitur. It's not actually a correct way of saying that, because the code can be almost anything. You can have all sorts of existing code for extracting visual features. You can have all sorts of existing code for talking to your cameras and your servos. And you can then just put a few lines of code at the beginning, at the end, and in the middle that turn it into a ROS node. Because basically, all ROS nodes do is pass messages back and forth to each other. So illustrated here by the green lines. And they pass them on these message boards that I was calling topics earlier, or they can communicate by something also called services that we don't need to deal with right now. But the basic idea is the little yellow circle around these guys is this wrapper. So you can either start from scratch and write in Python with all the bells and whistles that ROS or C++ that ROS has to offer, or you have this existing code that you just want to wrap up. Furthermore, ROS is fully network-centric, and that means it doesn't really care where the nodes are. And this is very useful, for example, when you want to run a very small, lightweight microcontroller board on your robot, maybe just for reading the sensors, even a laser scanner as far as that goes, and then you beam that data back to your laptop or your PC where you have all the horsepower to do visual processing and so on. So the red arrow there from the visual features assumes that, okay, we're going to need a bigger processor to do the OpenCV stuff. So we're going to send that over to a new node, which is the master node. And the master node's always running. That's the one you fire up first. And it's the guy that coordinates all the messages passing between all the other individual nodes. The other thing I put in that slide is that the visual processing could be RoboRealm running on a Windows machine. In fact, it could be so very, very easily, because if you're a RoboRealm fan, you know that it has its own network socket server. And so you can run RoboRealm on a Windows machine, do all the vision processing from the camera, and just serve up your variables on that socket, read that socket from your Linux machine and wrap it into a topic or a set of topics for the rest of the ROS node network to read. So it's fully network capable in that way. And finally, I don't think this slide is visible here, but ROS has this really cool little utility called RxGraph that lets you, virtually unreadable, unfortunately, but it's just it shows you how all the nodes in this head track. This is the actual graph printed out from when I run the head tracking process or application, and it shows you how each of the nodes in that graph are connected to each other, who's talking to whom. Okay, so this is just a brief little video showing OpenCV tracking an object, and the point of this, it's using something called I'm comparing OpenCV to my cat, and I'm actually not sure who's better. I think OpenCV actually has a little bit of the upper hand, partly because the cat just gets bored. But one of the things I really like about this camshift, and the reason I wanted to use this as a demo, is the camshift operator doesn't look just for normally, for example, in something like RoboRealm, you might do color tracking with a single set of RGB values, and you can give them some ranges. But the camshift algorithm actually tracks a histogram, and it was hard to see at the very beginning of this video, but I actually dragged my mouse over the green balloon, and it picked the range of green pixel color values on the balloon and plotted it in the histogram that you see below the picture. Anyway, you can see it actually tracks it very, very well. So it keeps the red circle around the balloon. So we started well. We have our camera image, and now we have our visual feature, which is the green color, the green histogram that we want to track. And we're going to put that on a ROS topic that basically defines the center of that region. So really all we need are the XY coordinates of the center of that red circle that you saw. And then in the end, we map those visual coordinates into a set of movement commands for the pan and tilt servos on the head. And so the pan and tilt servos move accordingly. And once again, we have a battle of robot versus animal. And of course, the iRobot is just sort of blindly bouncing around on things. But you can see that the robot obviously is just tracking that same color patch. We no longer see what OpenCV sees here. That was a little hiccup in the servo. And then it gets a little boring. What's that?
I said the cat and the robot, you can see like the head turns and then the robot head turns.
Well, one of the differences is that the cat is actually following the little ribbon that I secretly put on the back of the Create because she wasn't really interested in the balloon. So only the ribbon, and there's the ribbon there. Big attack. All right. So that's the head tracking beginning to end, and that's all done with ROS.